Hello everyone. In today's video we'll be covering the Introduction to Organic Part 1. Now this is your last lesson. Well, this is subdivided into 4 more lessons, but the entirety of organic chemistry is the last lesson in your AS chemistry. Yeah, and it constitutes for about 30 to 40% of your paper 1 and paper 2 marks, sometimes even 50%. It depends on the paper, right? And in today's video, we'll be covering most of the things that we'll be covering today are things that you're familiar with from your IGCSE years. But anyway, homologous series and their characteristics, types of formulae of organic compounds, different functional groups and ending names, IUPAC nomenclature, and lastly, priority grouping with examples. Now, the priority grouping, the entirety of it is something that's new to you, and some types of functional groups are different, and like a new type of formulae of organic compounds is introduced. Apart from that, everything is similar that we're going to cover today. So let's get to it. So firstly, the homologous series. Now this is something that you're very familiar with from your IGCSE years. So the homologous series share characteristics such as same general formula, right? Same general formula, and then similar chemical properties. And they also have, well, the last one is long, so I won't be writing it, but the physical properties show a trend in variation. So for instance, the longer the alkane chain, the higher its melting or boiling points, right? So those are just a few characteristics of the homologous series. Now, unlike your RGCSE years where you used to be asked this for like 2 or 3 marks, sometimes even 4, I haven't seen it being asked in your A-level chemistry, CIE, AS, and A-level. They haven't asked it ever. So just knowing this in the back of your mind is sufficient, in my opinion. There isn't much importance given to like the list of properties of homologous series, right? So let's move on to the next part, and that is the types of formulae. Types of formulae. If you haven't done IGCSE organic chemistry, then it's going to be a bit difficult for you to go into this lesson. So I suggest you recap, like just brush upon it, like very, very briefly, and return to this lesson as we'll be using, because I'm assuming that you're familiar with basic organic compounds such as propane, butane, or alkanes, and all that. The rest I'll cover myself, but the first two I am assuming that most of you are familiar with. So, for example, types of formulae. Now, there's 4 types of formulae. There's molecular, structural, displayed, and skeletal. Okay, so the first one, molecular. And for all of these, we'll use the example of propane, right? So, those of you who know the what like the general formula of alkanes, which is CnH2n plus 2. For propane, it's 3 carbon atoms. So the molecular formula of propane is C3H8. So this just like directly says like what the molecule is, right? Like you can't get more details from this. It just gives you the general molecular formula for the compound. The next is structural formula. The structural formula gives you more of an idea of like what it is, like what the compound is from the molecular formula. So the structural formula of propane is CH3, CH2, CH3, right? And when you're writing the structural formula, unless it's a double bond, I assume, do not give lines. So do not be like CH3, CH2, CH3. Don't do this, right? Just write it in the general standard, the structural formula format. Third thing is displayed, and this is something that you're very familiar with as well. So instead of this, you have lines in displayed. So there's the carbon backbone, right, and all the edges. This takes a bit long to draw, but I believe is the most preferred method amongst most candidates. And even in displayed, whenever you're asked to draw in displayed, do not draw like this: CH2, CH3, CH2, sorry, CH3. Do not draw like this. It's not acceptable. The entirety of the compound has to be in displayed form. Okay. And the last thing, which is new to you in your syllabus, is skeletal. And in skeletal, everything is drawn by lines, and we ignore the presence of etch, right? And we assume that each point on the skeletal is each point on the skeleton is a carbon atom. So for displayed form, like for propane, the skeletal formula would be something like this or like this, depends on you, right? So this one point, this is the second point, and this is the third point. Each of these points are a carbon, right? And CH3, CH2, CH3. So that is the skeletal formula. So let's have a few examples, like a few example questions. Okay. So draw each of the four types of formula, like molecular, structural. Okay, wait. Let's not draw molecular because that's quite simple. I'll give you the molecular formula, and let's draw it for structural, displayed, and skeletal. Okay. And for butane, C4H8. Go ahead and try it. Now the structural for butane would be, well, CH3, CH2, CH2, CH3. Another way to write it, if you're feeling lazy or if you want to be more simple, CH3, CH2, and because it comes twice, you give a bracket and 2 and CH3. Okay, that is one way to write the structural one, structural. Okay, and now displayed. So that'll be C, 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 and the entire backbone. Assume that those are the hydrogens. Okay. Yeah, I'm being lazy right now. And the last is skeletal. And for skeletal, 4 carbon atoms, ignoring the H. So 1, 2, 3, 4. Okay, or you can draw it like this. Sorry, wait, not that. There's way too many points there. Okay, you can draw it like this. Okay. Now I'll give you the displayed formula of 1, and you have to no. I'll give you the structural formula, and you have to draw the displayed formula of it. Okay. So the structural formula is CH3, 2, C, CH3. No, wait, that doesn't make sense. CH3, 2, CH, CH3. Draw the displayed and skeletal forms of this. Take your time, feel free to pause the video. Anyway, let's move on. So firstly, let's draw the two CH3s. So CH3, okay, and CH3. And there's a central C that's bonded to an H, right? So CH3, CH3, right? And CH3. So that's how it is. That's how. If you got it like this, then it's correct. For those of you who did it like this, right? Oh, and this isn't displayed, right? Oh wait, just ignore the scale. This isn't displayed. Like the displayed would have like that. That's displayed, but yeah, I'm just not gonna draw the edges. But if you got something like this, CH2, no, not CH2, CH3. If you got something like this, it'll be entirely wrong. The reason is because remember that carbon is in group 14, right? So it can at max be bonded to 4 other things. Like it can at max have 4 other covalent bonds. So in this case, you see this carbon atom, it's bonded to 3 hydrogen, 1, 4, 5. So it has 5 bonds. So this is just simply not possible, all right? So I hope you understood from the examples. If you do need more practice, just look up a few structural formulae of some compounds and then try to draw the molecular or structural formula of it. Okay. Most of the times when you're doing representations, do not give the molecular formula, because it is impossible to tell like what the organic compound is from the molecular formula. For instance, you see that I gave you that this is butane, right? This C4H8 is butane, but even this one is C4H8. So how would I know whether you're indicating this compound from C4H8 or are you indicating butane from this from C4H8? So do not give the molecular formula unless it's allowed to. Okay, just do not use it whatsoever unless it is mentioned. And unlike in your IGCSE years where you were forgiven for giving displayed formula when they ask you structural, do not do that in your A levels. If they ask for structural, give structural. If they ask for Molecular, give molecular. If they ask for displayed, give displayed. If you do not follow what the question says, they will not give you any credit. So let's say they ask you for displayed formula, right? And you gave a structural formula, something like CH2, CH3. You give a structural formula like this, okay? They will not accept this. The reason is because you didn't even read the question. Even if your compound is right, they will not credit you because you're not following what the question asks for, okay? So those are the different types of ways to represent the organic compounds. Now the next thing we'll move on to is the different functional groups and their ending names. Okay, different functional groups and their ending names. So regarding the different functional groups, there's many. You might get lost right now, but just bear with me. And as you continue doing more questions and learning, this is just like it becomes something like it's always in your mind. You don't really have to actively think about it. You don't have to be amazed or be astonished as to how much information or how many functional groups there are. The more you use it, the more it becomes muscle memory. Okay, so the most basic one is alkane. Okay, and in each of these we'll assume there's C2. Okay, alkane, and C2, right? And the name ends in A-N-E. So like if we have C2, that'd be ethane, right? So CH3, CH3. That is the ethane formula. The next functional group is alkenes. They are unsaturated. These are saturated, alkenes are saturated, whereas alkenes are unsaturated, and they end with "ene." And for alkenes, you have to give the number at which the double bond is present. Like alkenes have double bonds, right? So for alkenes, for example, C2 would be CH2, right? H2C, CH2. But in case you had like, let's say a butane, right? So butane can be CH, CH2, CH3, or it can be CH3, CH, CH, CH3. So these two are different compounds. They have the same molecular formula, but they have the different like structural formulas. So when you're writing the names of alkenes, make sure to give the position. So this, for example, would be but 1 ene, whereas this one would be but 2 ene, right? We'll get on to the IUPAC nomenclature in a bit, so just move on. So the third type of compounds is alkynes, but these are not really in your syllabus, but they have asked a question before which included alkynes, and they end with YNE, right? And alkynes, their special characteristic is that they have a C triple bond. Okay, so the simplest alkyne would be ethyne. So 1, 2, 3, 4. Okay. Now this is not in your syllabus, so you don't really have to learn it, but it's better to keep it in mind. Not in syllabus. Okay. The fourth type, the fourth functional group, is a halogenoalkane. Now this isn't a primary functional group, it's more of a secondary functional group. Like it doesn't take priority over like the main functional groups, and it comes in the beginning, like this. You know how this one ends in, this one comes in the beginning. So beginning, and it depends on like depends on what the identity of X is. So let's say we have CH2, CH3, right? And we have X, where X can be, well, it's a halogenous, so it can be F, Br, no, sorry, F, Cl, Br, I. AS is very, like astatine is not seen in your syllabus or never seen in your A-level chemistry ever, like as a halogenoalkane. So we just use FClBri, okay? And if it's F, it'll be fluoro. If it's Cl, it'll be chloro. If it's Br, it'll be bromo. If it's I, it'll be iodo, alright? And as for which to write first, well, we'll get into that when we cover IUPAC naming. And for these, you always have to give numbers. So not here because either ways will be one, but for example, this would be one, if the X were F, one fluoro ethane, right? So the names at the beginning. Now let's move on to the next functional group, which is alcohol. Something that you're familiar with from your AS years, not AS, sorry, your RGCS years, and it ends in OL. So CH3, oh, and it has an OH bond. An OH bond, like an OH directly attached to a C, a carbon. So CH2, and then there's an OH. Okay, so that's an alcohol, and this alcohol would be ethanol. The reason why I'm not giving position here is because even if it was on the other, even if it weren't the other carbon atom, it'd be first, right? The sixth functional group is aldehydes, and they end in Al. So the most simplest aldehyde, no wait, the most simplest aldehyde is methanol, but we're using C2, right? So, and in aldehydes, what's present is a C double bond O and H, okay? And there's an R, which is whatever the rest of the compound is. So for instance, we're using C2, right? So CH3, C double bond O, H. This is an aldehyde. This is ethanol, okay? Whereas the other group, ketone, is very similar but is not the same, and it ends in ONE, okay? And instead of this H, instead it has another R. An R can be any organic, like any organic chain. So two cannot be, like if there's two carbon atoms, there cannot be a ketone because it would end as an aldehyde. So we have to take propanone. Propanone, sorry, is the simplest ketone. So CH3, right? C double bond O, CH3, propanone. If instead it were CH3, CH2, C double bond O, H, this would be propanol because it has an H instead of an R group, okay? Now these are the two new things in your AS syllabus. Okay, now let's move on to the next, which is carboxylic acid, something that you're familiar with. Carboxylic acid, and it ends in oic acid. So ethanoic acid would be CH3CO2H, right? And in carboxylic acids, it's basically a C double bond O, OH, and there's an R. So ethanoic acid would be CH3, C double bond O, OH, right? So it's a double bond and then an alcohol, okay? Well, you don't refer to this as an alcohol, you refer to this as the OH of carboxylic acid. Sorry, not 8, 9. 9. It's esters, and it's a derivative of carboxylic acids, and it's il-OH, right? And il is the name taken by the alcohol, and OH is the name taken by the acid. So let's say you have propanoic acid and ethanol, so it would be ethyl propanoate, okay? And it's a condensation reaction that forms the esters between the alcohols and acids, okay? The next three are in your A2 syllabus, but I'll just include it here just in case, okay? So amines or amines. For those of you taking bio, you should be very familiar with this amine. It ends in amine. It's kind of funny. Anyway, and in amines, what happens is there's an NH2 or NH3 group. NH3 group. An amine comes from amino acids, alright? So, for example, for C2, CH3, CH2, NH2, right? So that is a primary amine. This is ethylamine. I believe this is ethylamine, right? Yeah, it has to be ethylamine because We'll get to the naming later, but this one's ethylamine. So if it's a simple if it's a simple hydrocarbon amine, not including the NH2, you make the name of the organic backbone as YL. So if it's if it's a propane in the backbone, it'll be propylamine, and so on, right? Oh, oops, sorry about that. Now let's move on. The next organic compound, or next functional group, is amide, and it's formed and it doesn't really have an ending, or the ending isn't important as far as I'm aware. But anyway, I believe it ends in amide. Okay, so in amide, the group is C double bond O N H. Okay, it's basically when an acid and an amine group they react via condensation reaction. It's from your condensation polymerization from your IGCSE years. Anyway, so this is an amide, right? And an example would be CH3, C double bond O, N H2, right? 1, 2, 3. So this would be ethanamide. And lastly is arenes. The most common one is benzene, right? And what it is basically this, or you can draw it as, but this is the more common used in our syllabus. Okay, and what this compound basically is a ring of carbons, a hexagonal ring of carbons. Okay, and the electrons are delocalized into the circle, into the benzene ring. Okay, and each of them have an H. This is the skeletal form. This is the skeletal formula. Okay, these were the skeletal formulas. So these are the different functional groups that we have in our syllabus. It's better you note them down. All right, and just have it in your mind at all times. At first, go ahead and refer to it whenever you need to. But over time, I believe that if you really learn properly, you won't need to refer to this all too much. Anyway, let's move on to the next part of our lesson today, and that is IUPAC nomenclature with examples. And this is something that most of you are also familiar with from your IGCSE years. So in IUPAC nomenclature, there's it follows a sequence, right? The naming of an organic compound follows a universally agreed sequence. And that's what the IUPAC nomenclature is for the organic compounds. So the first one is identify longest carbon chain, right? That is the first step. Second is identify the functional groups and add suffix. Functional groups and add suffix. The third thing is number the functional group and give it lowest number possible. That's the third step. Okay. The fourth step is look for additional molecules attached to the chain. And name them. Right? Fifth one is number the additional content. This additional molecules, number them, and give lowest possible. And lastly, just bring it all together. So that is the IUPAC nomenclature. All right. So let's take an example. All right. So CH3, CH2, CH2, CHCl, and CHO. Whenever there's a CHO, it's an aldehyde. Okay, so let's number this, or let's name this compound. So first of all, let's identify the longest backbone, or the longest carbon chain. So 1, 2, 3, 4, 5, right? And that is the longest possible carbon chain. So we have 5, right? C5, therefore it will be a pent, right? So it'll be a pent. Now identify the primary functional groups that are present. This primary functional group, there's only one, which is CHO. So it's an aldehyde. So it will be pentanal, right? And then look for additional compounds. Oh, and regarding carboxylic acids and aldehydes, they're always at the end, so we don't really need to number them. So pentanal, right? And Cl, it's either at 1, 2, 3, 4, 5, either at the fourth carbon, at the fourth position, or 1, 2, the second position, right? So according to the ruling, which would you give it, the fourth or second? Well, you'd give it the second position, because give it the lowest number possible, right? So when you put this all together, you have 2 chloro, right? So 2 chloro, 2 chloropentanal. Okay, so we follow the steps. Let's take another example. All right, I'll give you the skeletal formula this time. Okay, so name this compound. If you want to, go ahead and draw the structural formula out first to make it easier for yourself, and then go ahead and try naming it. Feel free to pause the video. Oh wait, before that, this is CL. Feel free to pause the video and give it a go. Anyway, let's give it an attempt. So for making it easier, first I'll draw the structural formula first. CH3, right? So there's 1, 2, 3, 4, 5. Yeah, there's 5. So there's C5. There's 5 carbon atoms. 1, 2, 3, 4, 5. CH2, CH, Cl, right? And then CO, CH3, right? And now this makes it easier for us to name, right? So we give it, so first identify the longest carbon chain, which is 1, 2, 3, 4, 5. Do not consider this, that is not carbon, that is chlorine, right? So there's 1, 2, 3, 4, 5, so there's 5, therefore pent, right? And look for the functional groups. So what are the primary functional groups present? There's only one. There's, what? That's a ketone, right? So that's on, right? So it'll end in an on, and it's in the second position, right? 1, 2. So the second position, not in the first position, because this CH3 is, this carbon is not attached to this oxygen. It's this carbon that's attached to the oxygen. So this is in the second position. And now look for additional functional groups or molecules. Oh, there's a chlorine. And which position is it in? 1, 2, 3, 1, 2, 3. Either ways, you'll get it in the third position. So it's 3 chloro. So let's put that all together, right? So it'll be the, like the secondary functional groups first. So 3 chloro, 3 chloro. No, wait, that was an error. Pent, 2 on. Okay, I hope that makes sense. Let's do another example, all right? Let me think of a compound. Okay, I think I've gotten a compound. So let's try naming this. Go ahead and pause the video if you want to. So regarding naming this, to make it easier for everyone watching, we'll first draw the structural formula. 1, 2, 3. Okay, and this is the fourth as well. So 1, 2, 3, 4. CH3, CHOH, right? CH2, CH3. Okay. Now let's identify the primary functional groups. The primary functional group is an OL, alcohol, so OH, right? And look for any additional functional groups. Is there any? Nope, there isn't. So we just write the final form. So give it the position 1, 2, 3, 4, or 1, 2, 3. So it'll get the second position. So 4. So it'll be butan 2 all. Right? So that is the IUPAC nomenclature. The more examples you do, the better for you. So go ahead and solve some examples online or look at compounds and try to give it the names and then check up the names later. Okay. Now let's move on to the final part of today. In this part, I'll just merge it with the IUPAC nomenclature as well, so that you have more examples to solve, and therefore grasp a better knowledge of what you learned today. Okay. So let's get on to priority grouping. And in priority grouping, for organic compounds, it states what you must name first and how the name would alter if one is present over the other. Okay. It doesn't make much sense when I say it, but once we do examples and once I show you, you'll understand more. So, firstly, the most priority is given to cations. And fortunately for you, this is not in your syllabus. The second most priority is given to carboxyls. And by carboxyls, I mean carboxylic acids. The third most priority is given to carboxyl derivatives. So they are esters, amides, etc. Right? The fourth most priority is given to nitriles. So what's nitriles, you may be asking? Well, nitriles is also another functional group. I believe it's a primary functional group, and it's when there's a C triple bond and there's an R, right? And it's given the ending name is nitrile. So that's a functional group that we forgot to cover, right? Anyway, so nitriles, the fourth most priority is given to nitriles, and if anything else, like any of these three above are present, sorry about that, if any of these three are present, when a nitrile is present in an organic compound, it gets the name cyano at the beginning. So cyano at the beginning. Okay, so let's say you have a carboxylic acid and a nitrile in one in a single compound. So the compound would be cyano something oic acid, right? So the fifth most priority is given to aldehydes, I believe. And the sixth most priority is given to ketones. And in case any of these above 6, any of the above 5 are present, in case a ketone is also, then the name you would give at the beginning instead would be oxo. Okay, at the beginning. So in case an aldehyde and ketone were present in the same organic compound, you would give oxo and then the organic compound al, right? So the seventh highest priority, or pretty much almost the last, is given to alcohols. And the name instead you would give at the beginning is hydroxy. And lastly is amines. And the name instead you would give is amino at the beginning. Okay, so let's do some examples of this priority grouping, alright? So, in case, okay, there's an OH, right? And, oh, sorry about this. Yeah. So, go ahead and try naming this compound. Anyway, so firstly let's draw the structural formula, right? So 1, 2, 3, 4, 5, 6, right? So C CH3, CH2, CO, CH2, CH2, CHO, right? This is an aldehyde. So 1, 2, 3, 4, 5, 6. Now you would give the aldehyde the smallest number possible, right? So 1, 2, 3, 4, 5, 6. So it'll be hexanal. Wait, hexanal, right? And what is the additional compound that's present here? In this case is ketone, right? So it would instead be right. So instead it would be oxo. One, 1, 2, 3, 4. So 4 oxo hexanol. Not hexa. Yeah, hexanol. Yeah. So that would be the case. What if you got a compound like? Okay, so what if you got a compound like this? What would you name it? Feel free to pause the video and give an attempt yourself. Anyway. Oh wait, no. That is not it. Yeah, that is it. So what would you name this compound? Feel free to pause the video now and give it an attempt yourself. Anyway, moving on. So identify the number of carbon atoms. 1, 2, 3, 4. Right. So CH3, CO, CH2, and CH2OH. So going back to the priority grouping, which would get a higher priority here, the ketone or the alcohol? Well, the ketone would get the higher priority, so we would treat this as the primary function group. So there's 1, 2, 3, 4, right? So 4 butan 2-on, and because there's an alcohol present that is treated as a secondary because of the priority grouping, it'll be 1, so 1 hydroxy. No, not 1 hydroxy. In this case, you're giving more priority to the ketone, right? So 1, 2, 3, 4. So this would be 4 hydroxy. Butan 2-on. Okay. I hope you understood. That is it for today's part. If you do have any doubts, please leave them in the comment section below, and please subscribe and share with your friends.